here. लेकिन okay, let's see क्या होता है. आप लोग बस अपनी तैयारी रखो. In kinematics and momentum, inshallah, you will be tested either tomorrow. Tomorrow is Thursday or Friday, inshallah, because I have to practice this topic in with topical questions, so that will help you out. Okay, so the last discussion about this topic is actually we were talking about the forces. So tension is one of the forces which is supposed to be discussed. Tension is that type of force which is produced as a resultant, I mean, as a reaction force. I mean, if you're not stretching a rope, there would be no tension. If you're not going to hang a load with a rope, there would be no tension in it. Spring, I mean, in the same way, when you are not hanging any load with the spring, there would be no tension. So tension is appeared when a spring or a rope or any object is being stretched, right? So there are different conditions. Let's say this is the diagram what you have to learn about. This is the body which is in equilibrium, and when the body is in equilibrium, if the force which is creating the tension, it is this way downward, then the tension will be upward. So direction of tension is very important for most of the students. When they are going to identify the direction of the tension, it is bit you know, problematic for them. Where will be the direction of the tension, so that they can manage that all. So direction of tension will always be opposite to the point where it is being created. Yani, because this is the end of the rope, and here you have applied the force to stretch it, so tension will be opposite to that. Similarly, if you are applying the force in this direction, then tension will be in this way, and so on. There would be different cases. I will explain you each and everything. So when the body is in equilibrium, then the tension will be equal to weight, and in that case, you can simply say that whatever the, yes, sometimes the question is asked, in case of the string, the tension is equals to mg, and in case of a spring, the tension is equals to k times x, deformation topic, and that is equals to weight. So you can figure out these all areas. But in case of accelerated motion, there are two type of problems which are usually asked to the student. One of them is that if an object is accelerating downward, for example, if you are having a weight and it is being lowered with the help of a rope and it is accelerating down, in that case, do you believe that weight would be greater than tension?
Yes,
So
definitely.
when the great weight is greater than tension, it means the net force is equals to weight minus tension. So net force is ma, so ma is equals to mg minus t. So simply speaking, it is not a big deal. You people are not supposed to recall all these equations, the bulk of equations, but you are supposed to get the concept of this, that the net force will be equals to w divided w minus t, right? In the same way, here I just managed one important thing for you. If the object has or if you are going to calculate the tension on the rope, that tension is basically measured with the help of a spring or a string or any meter, tension meter, which is usually called force meter. That can be mg minus ma. So if your body is at rest or it is moving with constant speed, your acceleration would be equal to zero, and then tension will be equal to just weight of that. But the problem is, okay, yeah, this all is here. If you see, did you see the weighing machine like that, which is having a round or any meter, and there is a rope along with that, or there is a Newton meter, which is basically a hawker is using to measure the weight or to measure the mass of some sort of raddi you provide to him. ऐसे ही होता है? Did you ever see?
Yes, sir.
So that machine actually measures the mass, and that mass is measured due to tension on this spring. But problem is there. Problem is that if we say that this is the tension and that tension is appearing on the string or the spring, then this is at rest or it is an equilibrium. Then its weight is equals to the reading over here. If it is not like that, then the reading will be false. And this is one of the questions, that why this is difficult for us to manage this load, that to measure that weight of this object is equal to the reading over here, because if it is not at rest or if it is not moving downward with constant speed, you cannot say that acceleration is equals to, or sorry, acceleration is zero. But when acceleration is increase, and now it becomes equal to value of g, then tension goes to zero. Then it is said that the body has apparent weight equal to zero. Remember this thing. Apparent weight is basically that reading of that tension or that meter which is being taught to you. Is this clear to all? The tension will be zero if the object has acceleration, downward acceleration equal to gravitational acceleration. Yani body is freely falling. Now, this is another area what I have discussed in terms of tension. Just see, there are some cases that in the tension here, I told you that you are going to have a rope, and that rope is attached with this block. Just see it, and the block has some forces to be resolved. I mean, I have resolved the forces on the block. So what forces are acting on this block? One force is,
Tension, normal
The gravitational
yes,
force.
yes, exactly.
weight, and
The direction of
up.
the tension is upward. Why? Because as I told you, that when uh, the rope is just held over here, and the force which is causing this tension, it is in this direction here. I have mentioned down the slope here. Here is that force. So that force is mg sine theta, because I have resolved the components, resolved the vectors into components, I resolved the weight into components. So tension is opposite to that force which is applied. So simply speaking, that mg sine theta is equals to tension when the body is in equilibrium, or normal reaction force is equals to mg cos theta. But when the body is sliding, sorry, when there is no, here there is no friction, right? In this situation, I did not consider the friction. So when there is no friction, that is the case. But in case of friction, just see, the friction is down the slope because body is accelerating upward. Sorry, body is moving upward with zero acceleration. Then tension is equal to what? The value of friction plus mg sine theta. Is it clear to all?
Yes, sir, clear.
Tension, value of
Yes,
tension
sir.
plus mg sine theta. So these are some cases in which we have to take care of the tension, direction of acceleration, direction of friction, etc., etc. So for example, here is the acceleration is downward, the body is accelerating downward, then definitely when it will accelerate downward, friction would be in opposite direction of that. So friction will be moving upward. So when friction is upward, now the tension in this rope is basically, let's say that it is held here, then the tension in this rope is how much? If the body is accelerating downward, then mg sine theta is now equal to tension plus friction. Are you getting my point? Or simply mg sine theta is equal to tension will be shifted upward, so tension plus friction will be equal to that. So tension is equal to mg sine theta minus friction. Yani if friction will be more, then tension will be less. Are you getting my point? That is why it is easy to slide down the thread or any sort of block on the frictional surface. Yani it does not rushes down. Are you getting my point? If it would be frictionless, you have to hold this rope very firmly. Otherwise, it would be just slide it down. So if there is friction, friction would be increased, so tension would be decreased over there. Is this all clear to everyone?
Yes, sir, clear.
Okay. Now here is, I think, on the on this page. Yes, it was just a test writing. Come on. Yeah, this is that concept of upthrust and tension together. There are a lot of questions in which upthrust, tension, and drag are put together by the examiner. So here I tried my best to give you as clear explanation as it is possible from my side. For example, if you're lifting a car which is submerged in the water, right, and there is a block, let's say, not a car, that block has some weight w, and you are applying upward force, constant force with the help of a motor, that will cause a tension in the rope, and there is an upward force, and then there is a drag in this. So I have applied all type of forces which are possible here. So Do you agree that these all forces will be acting here?
Yes, sir.
For equilibrium, sum of these two forces should be equal to sum of these two forces. So upthrust and tension together, they would be equal to weight plus drag. So simply speaking, if there would be more upthrust, you have to hold this with small tension. So tension will be less. But if weight is greater and drag is greater, then it would be very difficult to drag the object upward. So tension would be increased. So you have to apply more force. So moving on, this is how the object has a sort of, the concept of tension. Now let's say you have dragged the object to the top layer of the liquid. Top layer, it is not just submerged out, sorry, it is not immersed out. From the top layer, for any position till the top of the surface, the tension, upthrust and drag would be same, weight would be same, especially the upthrust will not change. So upthrust is the major force and weight. So if they are basically same, so the rope has, or sorry, the motor has to apply a constant force. But if the speed is to be changed, then definitely motor has to apply different force. But in some of the cases you have these type of questions, that is continuation of the same part, right? So just keep this point in your mind. Now the body is little bit emerged out of the liquid. So when this object has emerged out of the liquid, what did you notice? Yes.
That upthrust decreases.
Upthrust decreases, right? Because yani, the reason behind that is, when you are talking about upthrust, that was the force by which the object was being pulled up. So when the object is being pulled up, and that was, sorry, that was dependent upon the volume. What volume of the submerged volume of the object, not the entire volume. That was dependent upon submerged volume of the object. So did you notice that the submerged volume has been reduced? Yes. Did you notice this?
Yes, sir.
So when the submerged volume is reduced, because now some of the volume is coming out of the liquid, na? So when some of the volume is or some of the liquid, some of the object is outside the liquid, it means that the volume is reduced, and when volume is reduced, upthrust will be reduced. So when the upthrust is reduced, you are supposed to apply more force. Do you understand that?
Yes, sir.
So you have to apply more force in that case. So when you are going to apply more force, simply speaking, that now the motor has to be powerful. So if the motor is not powerful, the object will be sunk down. Okay, is it clear? Because weight is same. If the object is moving with the same speed, drag would be same, and tension is to be increased because upthrust is decreased. So that is the numerical analysis. I believe so that it is easy. And is it understandable, or did you people get it, or should I explain it with numeric values?
सर इसमें फॉर्मूला कौन सा लगाया सर आपने?
uh, Actually, the formula depends upon the values, sorry, the direction of the forces. For example, if you see that the object is moving upward with the constant speed, then tension is to be calculated on the rope. So drag is 15 newton, weight is 50 newton, and upthrust is 20 newton. So which force will be helping the tension? Upthrust. So this upthrust and tension will be in the same side, and drag and weight will be on the same side. So tension plus weight is equal to drag plus force, drag plus weight. So is this clear to
तो
all?
सर ये फॉर्मूला खुद निकालना होता है हमने इससे
Yes,
वैल्यू से?
exactly. Exactly. This formula is not any, hard and fast. This formula depends upon the situation and condition of the forces. For example, I will give
सही
you
है.
one more interesting fact. If I have, in yes, this is the question. of a past paper. Oh, come on. There is a there is a floating balloon or a boy that is just attached with a rope, and that rope is attached where? On the deck of the sea, or deck of the swimming pool. Then this balloon is having an upthrust like this. Do you think it would be upward? Is that na? Weight is acting downward, so it is in equilibrium, let's say. Then the tension is downward. Now upthrust is only upward force, and weight and tension, they are in the same direction. That's why I have added them together. So is this situation clear, that you have to make this equation by your own? In all type of situations, equation would be uh, formed by yourself. Is this clear to all?
Yes sir, ठीक है.
There is one more question I have seen. In that one, it is said that the sea water is there, and that sea water just pushes the balloon in this way, and the tension on the rope is in this way. That rope is held over here, right? And weight of the balloon is this way. This is the weight of the balloon. Then the upthrust is acting in this direction. Then tension is acting at certain angle theta. So you can calculate tension on the rope. So because now all the tension is not directly participating downward or to equilibrium, to create the equilibrium. So I have to resolve the tension into two components, right? One downward, one this way. For example, this angle is 30 degree. Then I can simply say that this is your T cos 30, and this is your T sine 30. So T cos 30 plus weight, they are combinedly equal to upthrust. So these type of questions are asked to you when you will be in practice. So you will be down to these, and inshallah, when you will see the questions right after this all discussion, they would be just nothing. They would be quite easy for you. Okay, is it clear to all?
Yes sir, clear.
Okay, then this topic, the calculation of pressure in the manometers, there are some questions in your past papers in which some manometers are being shown to you. Actually, there those manometers are having yani they are not having a different physics. Let's say this manometer is filled with some liquid inside. Suppose the liquid has density rho, and that liquid is filled in this, its density is rho, and some air is at the top of this, atmospheric pressure is there, and the pressure which is applied here, that is pressure of the liquid plus pressure of atmosphere. This is the total pressure. Oh my god, just a second. Who just leave the class? Who is not in the
आपकी
class?
स्क्रीन शेयर बंद हो गई है.
Okay, okay, okay. अच्छा, मेरी स्क्रीन बंद हो गई तो एक्चुअली आई जस्ट gone out of the game. Okay, what a myth that is. Just a second, guys. Now is it visible?
Yes sir.
Okay, so here I was talking about this all, that some calculations are based on, yeah, this was the question, man. Yes, I was thinking about the question. Huh? I have put that question here. So this type of question is asked to you. So if you are not having the clear concept of the tension and upthrust and angle and equilibrium of the forces, you will not be able to handle that. Is it clear to you? Just see, it is basically okay. So if it is in front of me, so I would like to explain that a sphere is attached by a metal wire, okay, and the horizontal surface of the bottom at the river, as shown in the figure, right? And that sphere is fully submerged in the equilibrium with a wire at an angle 68-degree to the horizon. So this angle is given, so I was basically selecting the angle here. So that is the same thing. The weight is 32 Newton, and the sphere upthrust acting is 280 Newton. The density of the liquid is given to you. Assume that the forces on the sphere due to the water flow in the horizontal direction, right? Assume that the force on the sphere due to water flow is in the horizontal direction only. This is the direction of water flow. That is the force of water. So by considering the components of the force in vertical direction, determine the tension in the spring, the tension in the wire. So I just told you that you have to resolve the tension into components. And did you see that the tension and weight both are directly downward, and upthrust is there? So sum of upward forces is equal to sum of downward forces. So upward is only up thrust, and downward is weight and T sine 68. Because this angle is given to you, that's why I have selected sine 28, 68. So from this all, you can calculate tension. Isn't it easy?
Yes, sir.
Yes.
Okay. So just keep the basic concepts with you. You will be just, you know, it would be amazing for you, and you will be practicing the questions. Now, here in this question, I was saying that what happened, there is some liquid in this container, so there is some air. So when air is here, so definitely there is an atmospheric pressure, and this is the pressure of the liquid. The what is the total pressure on the base of this? So total pressure here is equals to, total pressure is the pressure of the liquid plus pressure of the atmosphere. I can say that is equals to total pressure at the bottom. So you can simply make a manometer for the same setup. For example, if you have a tube, no need to just draw YouTube, it is the same, it would work, right? Let's say I have a gas supplied here. This is a gas container, and that gas container has some gas inside, and that gas is supplied to this. So this is basically gas. Okay. Then this container, I mean this tube is filled with liquid in this way. Are you getting my question? I mean the scene of this question.
Yes.
Okay, this is basically the liquid filled in, and this is open as well. So definitely atmospheric pressure will work as well. So this is atmospheric pressure. The question is, calculate calculate the pressure of the gas, right? Pressure of the gas mean how much pressure it is being providing you. So logically, if you say that from this point to this point, this is the liquid which is creating the pressure. So this is the pressure of the liquid. So that is the height, whatever that is marked, either it is marked X, Y, Z, whatever, it does not matter. So this is the height of the liquid, because from this point to this point, this height is equal on both sides. So it has no pressure, right? And here the gas is exerting some pressure here, and then air is exerting pressure on this side. So where is the point of interaction? Isn't it here? Because at this point the gas will be exerting a pressure upward through this liquid, do you understand my my idea or my opinion?
Yes, sir.
So pressure of the gas would be exerted here. This is the pressure of the liquid from the top, and this is pressure of the atmosphere. So it is very obvious that in this case, pressure of the gas will be equal to pressure. Sorry, gas has one S. Sorry, man. The pressure of liquid plus pressure of atmosphere or atmospheric pressure. So if you now the height of the liquid, it can be rho g h plus atmospheric pressure is usually given to you. If not, you can even calculate the atmospheric pressure if rest of the values are given to you. So this is how you can manage the manometer questions. One more thing I wanted to add here, that in some of the questions, as I told you, in case of liquid pressure, in case of liquid pressure, do you know that that depends upon what? The pressure of the liquid is equals to rho, G, and H. So if you have two liquids in a tube and those two liquids are of different densities, then what will happen to you? Sorry, what will happen to this tube? That tube will have different heights. Okay, let me draw this in this way as well. Right? Did you see these type of questions in your exams? I mean, in some of the topical papers, there are some. So, for example, this is a liquid which is of different color. It means its density is different. And there is another liquid whose density is, let's say, different. Sorry, right? It is filled till this point, okay, and this liquid is filled this way, so they would not definitely merge together. So can I say that this liquid has more height, this one, the blue one, the height of x is greater than height of y. Height of y, it means that the density of liquid x is smaller than the density of liquid y. Do you agree?
Yes,
Because
sir.
once its height is, yani once its uh, density will be less, it would cover more height for the same atmospheric pressure, because the atmospheric pressure is same here on both these tubes. So these type of questions are asked to you in your exam. So now I believe so that you are done with the article of types of forces, and yes, rest of the stuff, the only thing which is left over, that is your momentum, sorry, moments. Okay ji? What is left over? The moments from that section number 5 of your workbook. Is it
सही
clear
है
to
सर.
all? So please pace up. And this is also a topic, what yani forces, entire forces. I will take a test of entire forces together. So please ensure this, that if you people are ready for the momentum and kinematics by tomorrow, we can have the test of that tomorrow, and then on Monday we can have the test of all the forces. Meanwhile, I will be teaching you deformation and work energy power also, inshallah. Okay ji?
ठीक है सर.
Any
ओके सर.
question?
No,
Any
sir.
question from any student? No question?
नो सर.
Okay, see you
No,
then.
sir.